All right, this is another big section. This is an enormous chapter, chapter 2. I've said this before, but you will use the content from chapter 2 every single day for the rest of the year in almost every single question that we have. So hopefully you're doing well on it. Keep it rolling. These are brand new rules: the product rule and the quotient rule. I've already alluded to the power rule. That's just the derivative shortcut, as I referred to it. Check it out. The power rule here in red says d dx, which is one of the 4 ways you can write derivatives. Remember, you can call it dy dx, simply d dx. You can call it y prime or f prime of x. It all means the same thing. So derivative with respect to x. There's an invisible 1 right here that's now visible. Exponent times coefficient would be n times 1, that's n. Then it's u to the down by a power, so it's u to the n minus 1, and then times any chain rule that might occur. That du dx is simply a chain rule. What's the derivative of u with respect to x? They like to use the letter u in our book, which is fine. I see why they're doing it, and you'll see as well as we move ahead in the book. All right, the 2 rules that are brand new that you have never seen before are the product and quotient rules. And here's how they work. If you have 2 things that are being multiplied together, we call the first one u and the second one v. I apologize that our textbook and most textbooks pick the letters u and v. I can't think of 2 letters in the alphabet that look more similar than those. So I try to make my u's extra curly and my v's extra pointy, so I'm not confused. But if u and v both have variables in them, if they both have x's or y's, you have to use the product rule. And what you do is you go u prime times v plus u times v prime. Now, our book writes it differently. If you actually go into the book, they don't have it written the way I do. They have it written like this, which I just think looks a lot worse. Instead of calling it u prime, they call it du dx, which is the same thing. And then here's the v. And they switch the order, which I don't like. I like to use the commutative property and switch it back. The second part, uv prime, here's the u, here's the v prime. I think it has a much better ring to it when you say u prime v plus uv prime. U prime v plus uv prime. It's like a bad jingle. You get it in your head and you can't stop saying it. U prime v plus uv prime. You can't say u times dv dx plus du dx times v. I mean, there's no rhythm there. Let's get that out of there. The reason I reverse the order from the book is because I can. With an addition in the middle, it doesn't matter what order I add these 2 items in. So why not do it this way? Because the quotient rule with the subtraction, the order does matter. I figure if you're going to memorize this, and that is the expectation, why not have it look the same way both times? So when the order does matter, you're not writing it backwards. So again, I just wanted to throw the disclaimer out there that what you see in my notes is not what you see in the book, but it does mean the exact same thing. I know I'm biased, but personally I like mine better. So, all right, so those are the 3 rules that you need to know. I can prove the product rule and quotient rule. I won't do so in class due to limited time, but if you want to see a proof, just get with me and I'll be glad to show you how you can work those out. And actually the proof involves long-form derivative from section 2.1. Okay, here's my first example. Find the derivative, dy dx. I have 2 parentheses being multiplied together, so this is a candidate for the brand new product rule that we've learned. But before I do product rule, I want to do this problem actually twice. I'm going to start by foiling first, taking the derivative, and then I'll go back and redo the problem using the product rule and hopefully get the same answer both times. All right, so here's the FOIL method first. Rewriting the original problem, we have 8x to the 7th minus 16x squared plus 3x to the 5th minus 6. Now we'll go ahead and take the derivative, just using the power rule, really. 7 times 8, that's 56. Go down by a power, x to the 6th. minus 2 times 16, that's 32, x to the first, plus 3 times 5, 15, x to the fourth. And again, the derivative of a constant, as we've seen already, is 0. So that minus 6 is gone. Technically, since it is negative 6, x to the 0, the moment you would go 0 times negative 6, it's out. Okay, so that is the answer. And I use the FOIL method, good old FOIL from middle school. All right, I'm going to come back and do the same exact problem, but this time I'll use the product rule, brand new from today. So what you do is you call the first parentheses U and the second parentheses V. It really doesn't matter what order you do the U and the V in, honestly. And now we'll just take the derivative directly. No need to FOIL. U prime V plus UV prime. U prime, I'm going to write these over here just so I have record of them. It's a good habit when the problems get harder. U prime is simply going to be 16x. And V prime is going to be 5x to the fourth. I'm going to make them a little bit smaller and move them out of the way. Okay, there we go. All right, ready? The derivative is U prime V. So U prime, that's 16x times V, which I'll just copy down. Okay, U prime V plus U, which is 8x squared plus 3, just copying it. V prime, which is the 5x to the fourth. All right, that's the answer, but clearly it's not simplified. So let me simplify it up a little bit here. Using some distributive property, that's going to be 16x to the sixth minus 32x. And you can do distributive property from the back side here, so this plus comes down. Let's see, you can do this. 5 times 8, 40, x to the sixth, remember you add the powers, plus 15x to the fourth. Ooh, I see some like terms. Let me combine those. So we get, let's see, 40 and 16. That's going to be 56 x to the sixth minus 32x plus 15 x to the fourth. And that is dy dx, the derivative of y with respect to x. As you can clearly see, I got the exact same answer as I got on the last slide. Same exact thing. Awesome. So that was the product rule. Now I know what you're probably thinking right now. It's probably the same thing that I thought when I was a student. It's going to be the stupidest thing I've ever seen in my life. Why would anybody want to do that? FOIL is so much easier. And I'm with you. If this was a problem that I had to do, I would absolutely FOIL it 9 times out of 9. 10 times out of 10 even. But let me ask you a personal question here. You going to FOIL that? Probably not. What if it wasn't a 4 at the end? What if it was like a 40? You still like to FOIL? No, I didn't think so. Me neither. So here you need the product rule. By the way, if that was a 40 and you did FOIL it out, you'd still get the correct derivative. The only downside is you'd lose like 10 hours of your life that you could never get back. So let's call the first parentheses U, the second parentheses V. I'm going to actually go above and beyond with some color coding. I'll use a little red and blue here. So U prime is going to be 3 times 1, that's 3, stuff, to the go down by a power, which is squared. Now, again, I taught you a little bit of the chain rule. I haven't taught you the full story, but there is a chain rule on this. You look at the inside of the parentheses, the 2x minus 1. Does it have a derivative? Well, yes. It's 2, so you have to go times 2. Again, we're not supposed to know that, but I wanted to show you early so we could do more difficult problems at an earlier time. And that way, it won't be so crazy when we have to learn it for real. All right, V prime. What's that? That's also going to have a chain rule in it. The 4 comes down in front. 4 times invisible 1 is 4. Stuff, which is 5x plus 2, to the go down by a power, which is third, times a chain rule of 5. So when I go ahead and I write my u prime, I'm not going to write 3 times 2. I'll write a 6. And when I write the v prime, I'm going to write a 20, okay, just to save a step. Okay, enough clowning around. Let's write the derivative. dy dx equals u prime v. Okay, u prime is going to be 6, 2x minus 1 quantity squared. Okay, so that's u prime, and then v will just get copied. Okay, so that's u prime v plus u v prime. Okay, u times v prime. At this point, the calculus is finished, but the Algebra 1 certainly is not. There is no way in the world that that is going to be an answer that you will ever see online or in the back of any textbook, or any choice A, B, C, D on anything multiple choice format. No way. This can be greatly simplified, and that is the expectation. This is a rugged-looking binomial. There are only 2 terms. I've underlined them in black, but that's all you have. What do they have in common? Well, my eyes get focused on the 6 and the 20, which are the coefficients. They're both even, so I can factor out a 2, so I will. I also see that I can factor out some 2x minus 1s. How many? 2 of them. Remember, you got to go with the lower of the 2 powers. And in blue, I can see some 5x plus 2s. Let's take out 3 of those, leaving me with a large bracket. Remember back on like the first day of school that we got together and I said, here's some complex factoring that you may or may not have done in Algebra 1, but later on in Calc, you're going to be working these problems out, and you're going to come up with an answer like this, and it's not going to look like the back of the book. And I said, in the future, this will make sense. Well, the future is today. Here we go. If you leave an answer like that, you're not going to recognize it. All right, let's see what's left after I've factored. I started with this red 6. I divided by 2, so we have a 3. There were 2x minus 1s. Both of them came out. But there were 4 of the 5x plus 2s. I only took 3 of them out, so there's a 5x plus 2 to the first power still remaining. I'm not going to write the first power. We know it's up there. All right, this addition sign drops down. Okay, I have this blue 20. I divided by 2 way out front. That leaves a 10. The 2x minus 1 to the third, 2 of them are gone, but there's still 1 left. But there are no 5x plus 2s left because all 3 of these got kicked out front. All right, so that looks better, maybe, but certainly not simplified. So we're not done yet. Not by a long shot. We have to employ some distributive property. Yeah, woo, distributive. So it's going to be 15x plus 6 plus 20x minus 10. If you don't like the shape of brackets, you can replace them with parentheses. Brackets and parentheses are the same thing. The only difference is the shape. That's not really simplified yet, but I can combine some like terms. Let's start with the x's. 15x and 20x. That's 35x. Plus 6 minus 10. Minus 4. And all this stuff can drop down because it's already made the final answer. Don't forget about it. And that is the answer that we would expect you to get. And if you compare the difference between the green cloud and the black check mark step there that I first had in red and blue, they don't look anything alike. There is no 35x minus 4. There's no hint of that after the first step. So again, you've got to be able to do the algebra as well as the calculus in order to score on these multiple choice questions you're about to see. So that's the reason, one of the reasons I did the 2 review days in the beginning of the year, because this is going to happen quite often. And it's Algebra 1 that you may or may not have learned back in Algebra 1. This complex method of factoring binomial terms out and even negative-powered binomial terms out. Could be something that maybe Algebra 1 didn't do back in the day. All right, let's move ahead to number 3. All right, we have a fraction. There are x's in both the numerator and denominator, so it's definitely time for the quotient rule. Now, with the quotient rule, unlike the product rule, it does matter what order you do things in. The numerator must be the u, the denominator must be the v. All right, up top here in the corner, let's get the u prime and the v prime figured out. This will be a little easier this time. The u prime is just 3x squared. No chain rule on that. And the v prime is simply 4. All right. So dy dx is large fraction u prime v minus uv prime over v squared. I always like to start by writing the v squared. It's not v prime, it's regular v, just copied, getting itself squared. It's kind of a nice brainless break for myself. Okay, brain break over. U prime v. Well, u prime is 3x squared times v, which is the 4x plus 5. Okay, u prime v minus u v prime. So u v prime. And of course, v prime being 4, I just like to leave a space and put it in front. That's just an experience there. All right, let's simplify this. It's going to be 12x to the third plus 15x squared. I like to treat this minus 4 as a negative 4 distributing through. Just easier and more seamless. So it's going to be minus 4x to the third minus 32. Both of them get the negative, not just the first one. We do have like terms. 12x cubed minus 4x cubed, that'll be 8x cubed. And then the rest just gets copied. Plus 15x squared minus 32. And this is the derivative using the quotient rule. Now, like a lot of things, you learn something cool and then you try to use it all the time, even when you shouldn't. Here's a perfect example of it. Now that you know quotient rule, I hand you what should be an absolute layup here. It's like, hey, look, it's an x to the negative 5th power. That's really what that is. But I disguise it as a fraction, and people are like, u prime v minus uv prime over v squared. I'm like, oh, no, you don't have to do that. Just do it the easy way. Derivative of x to the 4th is 4x to the 3rd. Power rule. The derivative of this, you can just use power rule on it. It's going to be negative 5 times 1 minus 5x to the negative 6th. Done. Don't make it more complex than it needs to be. Now, to make you feel better about things, the quotient rule does still work here. It's just a step or two longer. For that second part, if I was to make a big fraction bar and go u prime v, well, u prime would be 0. So 0v minus uv prime, that'd be u v prime, which would be 5x to the 4th, over v getting itself squared. X to the 5th times x to the 5th is x to the 10th. I think you can see that this, after you cancel 4 x's, is going to be negative 5x to the negative 6th. So, yeah, I mean, quotient rule works, but you don't always have to use it. Which I guess would bring up the natural question, when do you have to use it? When don't you have to use it? Well, if you look at the example that we're on right now, there are not variables in both the numerator and denominator. There's a 1 up top, so I didn't need it. If you backtrack, to number 3 and you look at the original problem there, there's no way to get rid of those variables. You can't cancel out, an x from top and bottom, not legally. So you're forced to use quotient rule there. There's also no such thing as a product quotient hybrid rule thing. Like here it looks like, u times v up top, I'll do a product rule first, and then I'll have a fraction, then I'll do a quotient rule. Well, no, because you'd be sort of getting a second derivative of sorts and not even a correct second derivative. So, because you'd be taking 2 derivative type steps. No, you can't do that. If you have a problem like number 5, you have to FOIL the numerator first. You have no choice. So actually, y is equal to that. But then you can take that x to the 4th and bring it up top, making it x to the negative 4th, and that way you don't even have to do a quotient rule. As I wrote this, I just combined the like terms right here to make the negative 3x squared in the middle, in case you're wondering where that came from. Doing some quick distributive property, I'll finally have y rewritten. And now I'm finally ready to write my answer, dy dx, also known as y prime. And I can just use the power rule now. Negative 1 times positive 1, that'd be negative. X to the go down by a power, negative 2. In the middle, I've got positive 6. Negative times negative is positive 6. X to the negative 3rd, down by a power. And finally, minus 6. X to the negative 4th. So even though we learned some cool new things, remember, we still also have recently learned power rule, and that's going to be asked on some of these problems as well. So don't just think because you see a fraction, it's automatically quotient rule, or you see multiplication, it's automatically product rule. Sometimes there are ways around these things. All right, we're going to do one more example for day number 1, and we'll take a nice, well-deserved break. Find dy dx. Clearly a quotient rule problem here. There's no getting around this. You have to do it. So the numerator is, of course, the u, the denominator is the v. But let me stop you first. I have students who are great students, or you guys are all great students, but I have students who are just fantastic mathematical geniuses, and yet they get onto this test and suddenly people are beating them done with the test. They start to panic. They're like, why am I so slow suddenly? Or maybe you've just always been the person who finishes last. That's how I was in high school. I'd like triple check everything, which is good. I'm not knocking it. In fact, I encourage it. But what if I was unnaturally slow suddenly and people were just beating me done who never beat me done with tests and quizzes? I was like, what's happening? And I'll have students come up and they're asking for pieces of scrap paper, even though I gave them twice the workspace they would ever need. And I'm thinking, what is going on? Let me show you what I notice every year. And unfortunately, about 5% of you to 10% of you are going to still do this on the test. I'm just going to be like, I'll give myself a head slap. Ugh. But hey, I warned you. Just make sure it's the 10% is somebody else, not you. Here's what people do. They get super robotic and they make this the U because this is how they've been trained. And this is the V. And they do a U prime and a V prime over here. And they're not really thinking. They're just going through the motions. Don't copy this, by the way. I'm going to erase this whole thing. And then when they do their U prime V minus UV prime over V squared, they're multiplying trinomials times binomials, and they've got like large powers, and they're trying to combine like terms, and it's just a mess. It's like a dumpster fire of a problem. Instead, why not factor first? We teach factoring for a reason in the younger grades. It's to make your life simple. I've provided a problem that factors beautifully. X squared minus 25, you know what that is. I don't even have to tell you what that is. And not surprisingly, there's probably some 5s up top that are going to cancel. I do see the 40 there. I'm thinking 8 times 5. It's got to sum up the negative 3, so the 8 gets the minus. And the x plus 5s are just going to cancel straight out. Straight away gone. Now, u prime is simply 1, and v prime is 1. Talk about easy. And the u and the v are simply just x minus 8 and x minus 5. So here your friends are doing like 6-step, 9-step FOILs, and you're like, I'm multiplying by 1. Well, no wonder you're beating them done. It's not because you're faster, you're just clever. You factor first. Even if they don't like factoring, they're going to have to factor later because they're going to get this answer that's enormous, and your answer is going to be small and neat. And they're like, how did you get that? And you're like, oh, you got to factor that big monstrosity. Or worse yet, they might have to simplify using synthetic division. So, not cool. Please factor early. Don't let that happen to you. All right, let me get my fingers all limbered up here. U prime v minus uv prime over v squared. All right. All right, there's the v squared. All right, u prime v, that's 1v. It's just x minus 5. I don't even need the parentheses. I'll put them on. Okay. U prime v minus u v prime. Well, that's just going to be this. Now, that parentheses is necessary because you're going to do distributive property. So that's going to give you, oh, the x's are going to cancel out. Check it out. You're going to have x minus 5 right here, minus x plus 8. So x minus 5 minus x plus 8. Those are gone. The numerator is just a 3. It's just 3 over x minus 5 quantity squared. Or you could say 3 times x minus 5 to the negative second. That's fine as well. There you go. If you don't factor first, you will have to simplify down to that. And that could be an adventure in its own right. So always try to factor if the opportunity presents itself. Early is better. All right, that's it for day 1. Product rule, quotient rule, and of course, the power rule that you already knew. Now it has a formal name instead of just the shortcut. All right.